So guys, this is Strydom, and this is the week 6 summary. I just want to start off this video by saying it's my best attempt at a vlog. I tried my best to get my face on the screen by using my phone as a camera or a webcam. I just have it plugged into my computer here. The only problem was that I'm also using my phone as a mic. And that's a completely separate application, and I couldn't get them both running at the same time. I was struggling with it for like an hour and a half now, and I decided it's just about time to make the video, post it up, and go to sleep. So we'll start off by talking about what we did on Tuesday. Everybody presented their Arduino projects via screencast through YouTube videos, of course. I learned a lot of interesting things about the Arduino boards and how it can be used. Some specific ones that I can recollect right now being the one with the piezo, making all the different sounds by just moving your hands around. I thought that was really cool, and that I could implicate that in possibly the second Arduino project. And another one being the knock lock box. So if you do a certain type of knocking, that it'll unlock a box or basically tell the Arduino to do whatever you want it to, like the same way that pushing a button would. And I definitely want to possibly try and include that in my second Arduino project. So again, yeah, we just all presented our projects and explained what we did in each of our individual projects. Moving on to Tuesday, we had to come to class being prepared with page 30. Let me find the page. It was 30, 36, 39, and 41. And we just went over all these things in class on whiteboards. So if I could bring this up, where'd it go? This being the first one, the first board, and it had to do with this problem here. So the question is asking us to find the electric field at each of the indicated points, and we're given the distance between the two atoms, and we know that Na has one less electron and chlorine has one positive or one more electron. So it would be a negative charge and then a positive charge. And it also asks us to indicate the direction at each of the points that the net charge would end up being. So looking at the math, we initially left all of the variables in and just solved each equation down to the very last step before including the distance in for x, the charge of an electron in for q, and we knew that it would be at each of the points outside of these two atoms, it would be the difference between the two charges, and within it would be the addition of the two. So the first point, or the first equation here, is dealing with point A. Tell that it's a negative Q charge, and we were thinking direction, negative being direction in the negative X direction, so going to the left. If you think about the X, Y coordinates of a graph, and ended up solving it to net force of negative 6.44 times 10 to the 10 newtons per coulomb. And again, it's negative because the force is in or pushing in the negative direction. So looking at point B, the net force at point B, solve it down to the algebra, or using algebra, and then include the values in the calculator for the last step, and it was 1.44 times 10 to the 11 newtons per coulomb. And again, looking here, the two forces were working together to pull on this, so it's much greater than the forces, the difference of the two at this point. And then at point C, of course, we expect it to be the same as A, since these are the similar charges, or same magnitude of charge. And then these are, of course, the same distances from the two magnitudes. The only difference would be that C would be pointed in... Actually, yeah, no, they would be in the same direction as well. So that is quite interesting. And you can see here negative 6.43, which is the same as the 6.44. The 44 is just rounded. So looking at the next problem, let me find it here, the next page. Oh wait, no, it's not this page. Page 36. It basically asks us to determine the differences in the equations at all the different locations, a negative A being, in my mind, at the point at the positive 1 charge, and positive A being at the positive 2 charge, and of course 0 being in the middle, and each block is represented by a distance A. So what we found on the boards, let me bring that up, was that when X was on the left side of A, or less than negative A, then it would be the difference, or the addition, I'm sorry, so the two charges would be the same. So the addition of the two forces from each atom acting on it, since they are both positive. And so you can see that here, or less than A. I mean, I guess it's the same for the positive A. Here they're both positive, so they're both pushing towards the right. And in between, the one is pushing left or in the negative direction, and one is pushing right in the positive direction. So it would be the difference between those two forces at anywhere between negative A and A. And then looks like the next board, does this one show it? Between A and A. Okay, so this board finally shows the less than A. You can see that they're both negative, which has the same effect as them both being positive. You just add them, and of course, after distance is squared, it just comes out to it's only the magnitude of the value that represents the force. The sign just represents direction in these cases. So let's see what this is all about. Okay, so this board is the next page that we have to do, which is right here, and it asks us to determine the location, if any, where the electric field is 0 in each of these examples A, B, and C. So in A, it's already done for us. It's got a positive 1 charge and a positive 2 charge. The math is all done, and it finds an exact location of X in terms of A. And it makes sense that these two forces will be acting against each other, so X should be closer to Q in order to have the force from Q be equal to the force from 2Q, or the plus 2 atom, whatever it may be, charge. So at this point, the forces between these two are equal, and they're both pushing against each other, so it makes sense that that spot's there. Right here, they would both be pulling. So again, it's the exact same concept as in this one. I would think that X would be in just about the exact same spot, actually, because they're both pulling, so it ends up having to be closer to the plus or -1 charge, then the -2, in order to have the same pull from that one. And if we look at our board, we came to an answer of just about right there. We, I believe, used, we used the origin right in between, the spot right in between the two as the origin, so A was involved in both denominators. And we didn't solve down to an exact value, but I'm sure if we did that we would get the exact same value that they had on this page. For C, does not look like C. Looks like I forgot to take a picture of C, but by just looking at it here, we got a +1 charge, so we got a push and a negative. It only makes sense that you have to be much farther from the 2 charge than the positive charge, and the positive pushes and the negative pulls. So you would have to be over on this side for the so that you could be closer to the positive, or only the 1 charge, and farther from the greater charge, so that they have the same force at that point. And we did this in class. I don't know why I forgot to take a picture, but it makes sense that you'd have to be on the left side over here. And if we did the math, we could find the exact distance in terms of A. So that's as far as we made it in class on Thursday. David said not to worry about 41 for the interview. Material on the interview will be, where am I trying to go? So material that will be on the interview will be the sticky tape interactions. Like charges, of course, like charges repel, opposite charges attract. Both positive and negative charges attract insulators, but they do the same for conductors, but insulators a lot less, because conductors allow their electrons to move a lot more freely throughout the material, causing them to be polarized in a much more significant way. Sticky tape lab, we'll go over exactly, we need to refresh our memory on exactly the steps we needed to take to solve for charge in the sticky tape lab. He says CSI, electricity and magnetism, which is the talking about basically having to backtrack after finally figuring out what a charge was in the first few weeks, and then backtrack saying, oh, then we must know that, you know, the rod was positively charged after being rubbed on the rabbit hair. And moving on to fields, and basically everything I just went over, page 30, 36, 39. We need to be able to read some Arduino code and be able to tell what the code will be saying. He said it won't be too difficult. It should be pretty simple. And we should be ready to during the interview week do our Arduino extensions, and we could start working on our presentation too. So I'm getting it pretty close here to 15 minutes. I think I'm going to wrap it up and finish my week 5 summary here. I'll see you guys on the next one.